Okay, this video is going to give you a quick walkthrough about how to do exponential and linear word problem questions. The first thing you have to do is be able to recognize things that we've known from before. You've had things that you worked with before that were arithmetic and geometric. The arithmetic ones added and the geometric ones multiplied. If you had to find an adding amount, you always did next minus previous divided by the gap, and with multipliers, you did next divided by previous. Hopefully those two structures are familiar to you as well, where you had to find some starting value plus what you added by times n, and with geometric ones where you found the starting value times a multiplier to the power of n. Your structure of equations today are going to follow those same formats. For linear, you're going to use y and x instead. And then you're also for linear, you're just going to still have a starting amount and an adding amount. And with exponential, you're going to still have a multiplier and a starting value that you're going to put together to make an equation that has a power of x. So now as you read these questions here today, there are some phrases in the word problems that need to tip you off as to which way to go with these kinds of different calculated equations. So when you read a word problem and it talks about going up by the same amount at a constant rate or something that's steady per whatever it is amount of time or per whatever it is that you're working with, constant rates, same amounts are going to be linear. And again, that's a u trying to find an add amount and then how it goes from the starting value in that equation. And then you're also going to see some word problems that deal with percentages. If it says, hey, something's increasing or decreasing by a percentage, that's going to be your tip off to do this kind of stuff with exponential type calculations, where you need a multiplier. And you learned in our previous lesson how to turn percentages into multipliers by doing things like this, okay? So we'll talk more about that in just a moment, but that's what we have for the intro part of this lesson today first. Now, let's go through some of these questions and decide what kind of question is it. On your question number 1, it talks about James was reading and he was about halfway through his book. He was able to read at a constant rate. Well, right there, that's our tip-off that this is going to be a linear question, okay? Constant rate. So now, the next thing is once you recognize that it's a constant rate, we're looking for some kind of adding amount, okay? But before we do any word problem like this, you want to take the information and put it into a table. So just create your own little XY table like this. There's my X and there's my Y, and then we're going to put our information in the table. Well, I first of all have, it says he was reading at a constant rate and he was on the third hour. The third hour he had 100 pages. And then it says on the 7th hour, he was then up to 172 hours. Now, as you try to do this, don't forget that the adding amount is calculated, since we already recognized that it was adding at a constant rate, right? The adding amount is found by doing next minus previous, and you're going to divide, previous, as a parenthesis, divided by the gap. And on your calculator, make sure you use parentheses, otherwise it does not do the calculation correctly on your calculator. So let me pull out my calculator here next. Let's try to put that in there. I'm going to do 100. Nope, that's my previous. Next, which is 172 minus 100, we're going to divide that by the gap, and our gap here is 4. So we'll divide that by 4. Let's see what we're actually going up by. How fast is he reading these pages per book? So go parentheses, 172 minus 100, close the parentheses, divided by 4. He is reading at a rate of 18 pages per hour. So that means the adding amount equals 18 pages, I'll just abbreviate that, pages, then per hour. All right, so now with that in mind, that means as you're going down this table building it, it's adding 18. Well, we also need to figure out what he started at. He started at hour 0. So we need to go backwards and not only add 18, we're going to subtract 18. And you're going to do that 3 times to get back to the 0 term, so times 3. So then I'm going to take my calculator and figure that out. I'm going to go 100 minus 18, and I'm going to do that 3 times like this. Subtract 3 hours worth of reading, and that's then starting him on page 46. So page 46 is where all this starts. And then lastly, you want to write the equation. What did it start at and what are you doing to it? Well, it's y equals, it starts on page 46, and then it adds 18 pages per hour. And it's always times n, or times x when we're doing a linear type relationship. Now, the next part it's going to ask you in the word problem is to fill all this information in. First of all, it said constant rate, so we're going to choose linear. The rate, how many pages did he read per hour? That was 18. Then it said, what did he start at? We worked our way backwards to 46. And then we wrote the equation, y equals, started on 46, added 18 per hour, or times per x, okay? And then the next thing is, it's going to ask you a question, how long until? There are 2 ways we're going to learn, but one steady way that I want you to use today, because when it asks you how long, we're going to try to use the table in our calculator here for that kind of part. But before we do that, let's talk about how you can do it algebraically first, for the linear ones at least. I know that if he's going to be on page 406, I can put 406 in for y, 406 in for y, and that will then equal the rest of the equation, plus 18x. So I could finish this, and I hope you can too, solving this equation by subtracting 46 and dividing by 18, and you'll already have your answer for this question. But on the other ones that are exponential, you're going to need to use a calculator skill to answer those questions when they ask how long until something is going to happen. So we're going to practice that with the linear one here as well. Let's put that equation into our calculator and just say 46 plus 18x, like this. And then what you're going to do next is you're going to go to the table. Right above your graph key here, it says table. We're going to watch the pages grow from the 46th amount of page, or the page 46, and then going up 18 per hour. Let's check the table out. So I go to 0, there's my page 46, and then I'm going to scroll down until it gets to page 406. If I keep going, I will find how long it takes this way as well. And as you'll see, it worked out perfectly this time, where it's perfectly at 406. So the answer is going to be 20 hours. So the answer to this last part, when it says, how long will it take the person to read to page 406? It's going to take 20 hours to do that, or the 20th hour of reading. So you use your table scrolling around after you've typed in the equation in the y equals of your calculator. The how long until questions will be very easy to answer. Now, the next thing I need to talk to you about is number 2. Number 2 is a question that talks about something that is not linear. It's talking about increasing, or in this case, decreasing by 8.5%. When you see things that decrease by percentages, we got to think back to our skills that we have from before that deal with changing percentages into multipliers. If you ever have a percentage that's going to be increasing for the word problem, then we want to add it to 100, and then take the result divided by 100 to get the multiplier converted. If your problem is a decreasing, like we have in our computer problem right here, it's decreasing by 8.5%. You're going to take that decreasing amount and subtract it from 100, and then you're going to take the answer divided by 100, and that'll turn that into the multiplier also. We can't work with percentages unless we turn them into decimals, so that's what we're going to do next. So for this question right here, let me get my eraser here. Well, I don't have it, but we'll use this. All right, take the information that we're given here. Let's talk about what we know. Well, that we know that this person bought a computer for $1,200, so that means he started with the cost of this computer at $1,200. So that's like our starting value when you write the equation of the exponential that we're trying to find here. So the next thing is 8 years ago is when he started, so that means then 8 years forward is today, now, okay? But before we can write the equation, we got to turn this percent of 8% depreciation into a multiplier. So our multiplier is going to be found by doing this. Take your percent and subtract it from 100. So we got 100%, subtract off our 8.5%. Well, that's going to give us 91.5, so that equals 91.5%. But then you're going to take that 91.5% and divide it by 100, and now your multiplier is now going to equal 0.915. Use your calculator if you need to, but just take 100 minus 8.5, which is 91.5, and then divide the answer by 100, you'll get this answer right here of a multiplier of this. So now that you know the multiplier, and you also know what it started with by what it told you in the word problem, we can now write the equation for this exponential. It'll be y equals, started at 1,200, and then it multiplies by 0.915, and again, multipliers are going to always be to the power of x, like this. So now we can answer all the blanks except for the last one, where it asks how much is it worth now? That would be 8 years later. So let me just get it out there right now, and we'll fill all the blanks in here to show that it works. But the last thing is you're going to take the equation that you've just found, put it in your calculator, and then parentheses, and I got 0.915 to the power of x, like this, okay? So there's our equation of the computer, purchased at $1,200, depreciating at 8.5%. Go to the table, and let's watch this computer lose its value. So it started there, now it's going down in value each year. Obviously, there's newer versions coming out. And then now we're on the 8th year, which is now, because it was 8 years later when you bought the thing, and now today, 8 years later. Make sure you put your cursor on the number. Yes, you can see the pennies right now, but you're going to have longer numbers in your homework today that go off your screen right here, and you're going to need to put the cursor on there so you can actually read the whole number at the bottom of your screen. This skill is so important because you're going to wonder, if I put in 589 for the answer, it's going to mark it wrong. You have to have your pennies correctly also written as well. So it's 589.59. So the answer is going to be 589.59, rounded correctly also for the actual now amount, okay? And we got the now being 8 years later from when you started. Using the table to get the answer right there, okay? So then I'll put that information in here to show you how to fill this in. So you got exponential equation because it went by a percentage. We got 8 years ago, it started at $1,200. And then we also had a multiplier for the situation that was 0.915, whoops, 5. And then we also had the equation, y equals, started at 1,200 and multiplied by 0.915 to the power of x. Shift 6 and then go x like this. And then the last thing was how long was it, or how much was it 8 years later? The thing was worth $589.59. Make sure your homework problems, when they talk about money, go to the nearest penny. And after you submit this one right here, I hope you and the rest of you that have tried this question here will get it correct. Oh, I didn't put my last one in here. That took 20 years to get there. To get the whole thing correct by doing that like that. You will look through more questions like this that talk about constant rates or same amount. You decide, and then decide from these different problems in the rest of the assignment. Good luck, and I hope this video helps.